use a lot of different levels of measurement because almost everything we do is ratio, which is the very highest level of measurement types that we have. But just so that you know what the terms are called, especially if you're going to use SPSS. If any of you are going to end up doing statistics where you're going to use that particular software, you must identify your data every time. So if this was the list that we wanted to put in, we wanted to find out how fast the swimmers were, and these 5 were the swimming people. And so in SPSS we would be listing our first column would have these in it, and we would call these, this is nominal. That's the lowest level. We can do absolutely no calculations with it. It's used to define something. If you're wearing a jersey with a number on the back, that defines who you are. But as far as doing any calculations with it, it doesn't work. Lowest level, that's called nominal. And then the next level up that we have is ordinal. And you can remember it by the word order. And what it means is where you rank. So let me think if I can think of somewhere. Well, I know. So I could ask you something like giving you 5 choices or 3 choices about good, better, best, right? Or you don't like, you don't care, you really like. Those are considered to be ordinal. We know where you stand, but we don't have a number to represent it. We don't know how far apart bad and good is. So it's called ordinal just because there is a ranking. So do you understand if we had some breakfast cereal to try, and we rank them by, this is the one you thought the worst, this is the one you thought was just okay, and this is the one you thought was the best, that would be ordinal ranking. Okay? And the third one is interval. And it just means that we know the distance between them. So temperature is 1 that we could use here. And I use the term distance between them. We know that if the temperature, we know 1 degree or 2 degrees or 3 degrees, those are all the same size, right? I'm going to say dress size, but that's another example, but not always good. That, you know, you wear a 2, you wear a 4, you wear a 6. The sizes are supposedly going up in equal amount. But the last and the best one is the one that we use, and that's called ratio. And ratio, the numbers have some meaning, and there's a 0 point. No 0 point in all the rest of them. Because most of the work we do is in numerical data, it's all going to be falling under the ratio section. But there are times that you, well, especially as I said, if you work on SPSS. So if you wanted to do a Likert scale, you might be sitting here. You know, how much did you like this? And you mark the dots. So in your textbook, that is on page 13. Just want to make sure I covered that because I didn't do that in the first class. Okay, so let's move on and do some review of yesterday by choosing some different data. One of the things I want you to understand is that it doesn't matter what data I start with. I get a choice of making it into whatever shape, a frequency distribution, cumulative frequency, a histogram. That's your choice as a statistician of how you want people to see it or what you're trying to show. So I'm on the bottom of page 33. We have enough textbooks? Please sit where there is one. So I'm going to look at number 12. And it says the Quick Change Oil Company has a number of outlets in the metropolitan Seattle area. The daily number of oil changes at the Oak Street outlet in the past 20 days are. Okay, so we have quantitative data. Do you agree? Because that's always going to be the correct answer for you, because we can't do statistics with words. And is it discrete or is it continuous? It's discrete, yes? We're only counting the number of oil changes done, not how long it took. If it was asking about time, it would be continuous. And we know where this is. This is in Seattle. And remember, even though this book seems to be wordy, the number of oil changes may be different in another city, even if it was still in the same state. Okay, so the first question says, how many classes would you recommend? Well, before we do that, let's enter it into the calculator. Let's find the max and min, because you always want to know that. You need this one. So remember, we go into stats, edit, and we're going to put them, shall we put them into list 1? Oh. How many pieces of data do we have? 20. So you know when you've entered that you end up having to have 20 pieces of data. Okay, so remember, what did this tells me? That I'm in list 1 and I'm about to enter term 21, but I only want 20, so I know I'm at least that far correct. Then I'm going to put them in ascending order because I want to know the max and min. This is your job. You're going to be a statistician, so we need to know what range of numbers we're talking about, and that's the term we use, range. So stats, sort A, and if I don't tell it, oh, in this new it does. I need to tell it that I need it in list 1. Okay, so let's go back and check. So the smallest number of oil changes that they do. So what min is 51 max. How is it? 90?
8.
Okay, so we would now say that the range would equal, and we subtract. So we want to know min and max, but we also write how many numbers it covers. So here, 98 minus 51. So we're saying it covers 47. So we have a rule now. We're saying that we need to cover 47 numbers. So we want to know how many classes to put it in. What's our n value here? How many terms do we have? N is equal to 20. So the rule, and this is, I want to use quotations around the word rule. It's a guideline. You are not going to use classes that are too unpleasant for us to notice. Like I wouldn't do 13, 17, 21 because that's not a regular way of us counting. I would do 10, 20, 30, 40, 10, 15, 20, 2, 4, 6, 8, any of those that we're comfortable with. But we wouldn't do it if it wasn't pleasing for our eye or for us to see. So the rule is called 2 to the k, and it says that we must have 2 to the k must be greater than n, in this case 20. So let me put that in here. 2 to the k must be greater than n. So the powers of 2, if I have somewhere to write, oh, down here, I'll write. So our powers of 2 are 2, 4, 8, 16, 32. So this is the one we need. You see, 16 will be too low. And this is 2 to the 5th. So we're recommending that you have 5 classes. So the number of classes is equal to 5. It's a recommendation. It is not a rule. Well, they call it 2 to the k rule, but I don't have to stick with it. I might end up with 6. I might end up with 4. Do you want me to go over that again? 2 to the k has to be greater than the number of terms I have. So whether I'm talking about oil changes or I'm talking about babies or eggs, if I have 20 terms, I'm always going to have the same line here. Okay, and then to decide how big the classes are, I'm going to take the range, so class interval is equal to the range divided by the value we've got here. So in our case, we're dividing 47 by 5. What do you think is a good guess here? I can't write on this edge anymore.
Why don't I get the calculator over here? We can put the calculator there, and then you can
that would be perfect. Okay, so when you have any set of data, you're going to write min, max, range, and n right off the top, no matter what we're doing. Hypothesis testing, whether we're going to do graphing, whether we're going to do central tendencies, it doesn't matter. So here, our class interval is going to be the range divided by the value that we've got here, the 2 to the k value. So in our case, 5. So we're saying that's 47 divided by 5. I'm going to put an approximately equal to 10. I'm not going to try to do this at 9.6 or whatever it is. So let's see what that looks like. So our class, our smallest value is 51. So what do you think I'm going to start with here? Remember, I want to be able to count easy. I'll do it. Count easy forward. Questions?
Yes, about number 5. What do you get the 5?
It's called the 2 to the k rule, and it says that, and it's just a guideline. So we're saying this: that 2 to the power k has to be greater than the number we have. So this, if I put it here, it's k. Okay, so here our value is 20. So the next one, power of 2 greater than 20, is 32, 2 to the 5th. And we're happy with this because we can count in tens. We didn't want to do 51 to 61 to 71. It's because when we put the raw data together, we know anything beginning with a 5 is going to be in our first class, anything beginning with a 6 is going to be in our second class. Okay, so frequency, and because we have the values all in the calculator anyway, and because I want to review the histogram, let's let it do it for us. Okay, so we're going to go into window, and we know that we're going to start at 50, and we're going to finish at 100. And we want it to go up in classes of 10 or in groups of 10. We've decided that here. And my rule of thumb is taking half the data and making that y max. Questions about this, the first part. We know that we have to represent this. Will this be exhaustive? If I graph from 50 to 100, am I guaranteeing all of my oil changes will be in the picture? So it's exhaustive. And it's mutually exclusive because they only can fit into one group. I can't have 50 fit into here and down here. Okay, so stat plot. The first one. Make sure you have it turned on. And this time I want to do a histogram. Let me stop. Is there anyone that doesn't know what's going on?
This step.
You went to stat plot, which is second y equals. Everything for stats is in blue. Yeah. Questions about the histogram? And I could have counted these myself. I know you could have as well. And on a test, you're going to have to do some counting on your own because, well, no, you could still use the calculator in graphing. So I'm going to go under trace. And I always go under trace anyway to make sure that it's graph what I'm expecting. It says that it's plot 1 from list 1. My minimum value is 50. The maximum in the first one is less than 60, and there are 4 of them. And the next one, 5, 6, oh, it's got nuts. And how do I know if I'm correct here? Must be 20 here, yeah? So, you notice that this question says, how many classes would you recommend? We've said 5. What class interval would you suggest? We said 100. I mean 10. Or you have something in the y equals. What lower limit would you recommend for the first class? Organize the number of oil changes in a frequency distribution. We've done it all. It's a beautiful thing. Yes? So, in a sense, it's a cluster. We could say that we would expect from 50, 60, 70, 80, maybe between 50 and 80 oil changes. If we wanted to do this as a frequency distribution or a frequency polygon, what would we have to do next? So if it's a frequency polygon, I need to have this one in. And I need to have this bottom one in. What else do I need? I need a midpoint. Remember, the calculator will just absolutely freak if you gave it 40-50. So I need a midpoint. I'm going to put it out here just so that you know that's the x value and the frequency is the y. So what's halfway between 40 and 50? So 45, 55, 65, 75, 85, 95, 105, and 115. No, just 105. Do you remember how to graph these? We're putting I'm going to put it in 2 and 3. I want you to be able to see the frequency polygon on top of the histogram. It allows you to graph as many pieces as you want. So first of all, I'm going to change my window, and I'm going to start at 40, and I'm going to go to 110. Everybody understand why? It's a frequency polygon. It must begin and end on the axes. Okay? Then I'm going to go into Stats, Edit, and in List 2, I'm going to put the midpoint starting at 45. Up to 105. And in List 3, don't forget to start at 0. 0, 6. Okay, first of all, any questions? We're putting the midpoint in. This is a representative, this is group. And once we start doing mean and median and mode and standard deviation, I'm going to show you that it makes very little difference if I start with raw data or if I start with grouped. So we started with raw data, we've grouped it. We're now going to graph the frequency polygon. We have to use a midpoint as a representative. We have to start at 0 and end at 0. So I've chosen List 2 and 3. I want to be sure that I can see the histogram and the frequency polygon together. So when I go and graph, stat plot, this time I'm going down to number 2. Do you see? Because if I leave one on, I will still get the histogram. I've now moved down to plot 2. So my first job is to turn it on. And my second job is to find the frequency polygon. It's number 2. The first one is a scatter graph. It will give you the dots, but it won't join them up. So we need to have, this is like a line graph. And you have to push enter to make sure that it takes that one. And where is our stuff? Line 2 and line 3. And this time I'm going to use the crosses because the boxes were so big. Beautiful. Questions? Questions about the calculator, questions about the stats part of what we're doing here. And again, it's your choice. You wouldn't, well, very unlikely give them both of these on top of each other like this. Some people do. But you would decide what you think is the best selling point that people can understand by looking. Sometimes we would rather have a percent than the number. Here, we only did 20 days. Maybe 20 days isn't enough. So if I make it relative, i.e. if I make it a percent, nobody knows how many days. Yeah? So that's, and it's called relative because we're talking about a percent. Like relative humidity. When they tell you the relative humidity is 70%, it's going to be maybe raining. By 80%, much more chance. By 90, we already know it's going to rain. It's not a number that is measuring raindrops or weights of clouds or anything like that. It's just the chance. With everything they know, it's a chance. It's a probability. Okay, so here, how would I know what percent of the oil changes were done from 50 to 60? What percent? What would I divide this by? 4 out of 20, yes? But I don't want to do that by hand because the calculator can do it for me. So rather than go through and divide each of these by 20, let's go back, stats, edit, and I'm moving on to list 4 now. And you want to highlight list 4. Once you're at the title of any list, you can ask it to do anything. And it will say, oh, so you want me to divide everything in list 3 by 20. That's what we want to do. I don't want you to go through and have to do it by hand. So I'm going to say to it, please take list 3 and divide by 20. Now, if I want a decimal, I'll stop now. If I want a percent, I'll multiply by 100. So it's your choice. We'll leave this as a decimal, okay? Everyone understand? I've highlighted, I'm saying to the calculator, in list 4, please take list 3 and divide by 20. Enter. So I have the percentages now. So that's... So if I wanted to regraph, so sometimes the calculator, I can't do it on the calculator, but sometimes what we would do, we would have something that looked like this. So... So I would start with the values from here, like our frequency polygon is there for this one. But on this side, I would write the percentage, so I'd have both. If I was just presenting and I didn't want to put the actual frequencies in, I could ask the calculator to graph the midpoint line and the percent. Yeah? Questions about this? And you can see it's a lot easier for someone to say, what, 30% of the time they're doing 6 oil changes or whatever it was, between 70 and 80 oil changes. That's good to know. That's a lot easier than just knowing that it happens 6 times. Yeah, 30%, I would read this 30% of the time, there will be 70 to 80 oil changes done. Questions? Stop me because I'm on a roll now. So everybody can do these first steps. Okay, I'm going to take this off. What about the last type, which is the cumulative frequency? We're going to fit into here. And we're going to start by saying less than 50. How many days did they change less than 50 oil changes? 0. It must always start at 0. And how many days did they do less than 60? Now you just don't want to speak to me, or you don't know?
Enough coffee.
Maybe I need a swig of tea while I'm waiting. Come on, how many of those 20 days did they do less than 60 oil changes? You can read it off the graph, yeah? 4. And less than 70, that means less than 70, I'm adding these two together. 9. You have 9. Less than 80 will be 15. Less than 90, 17. And less than 100 had better be all of them. This is how you tell if you've done this correctly, because when I'm finished here, I'm saying, what's the chance of it being more than 100? It better be 0. Okay, just to be sure that we can graph those as well, let's put those in list 5. But I've got to be careful now, don't I? Wait, not list 5. I need to put these in. I need to put this in list 5. So I need to put 50, 60, 70, 80, 90, 100. And in list 6, I'm going to put 0, 4, 9, 15, 17, and 20. So I'm going to go back to the window. My window's different now. I need to have y up to 20. Cumulative frequency, I need to have the max to be the max of my range. So 40 to 110, I could basically, is fine. And I'm going to make it, instead of going up to 10 to 20, I'm going to make it go up to 25. Only because the window will be crowded, right? If I make 20 the top of my window, I won't be able to see the top of this graph. And stat plot. I'm going to turn off the first 2. So I've turned off the histogram. Look at the top, I can go to plot 2. I'm turning off the frequency polygon, and I'm moving on to plot 3. And I want it on. I want what type, the second one. And I have my stuff in list 4 and 5, or 5 and 6, 5 and 6. Questions? Can I confidently sit down and think that all of you could do this? All right, I'm doing that. I'm assuming everything's fine. I'm looking at question 13. Lots of data now. But when your first assignment, which you will hopefully get tomorrow, it will have loads of data, because if you are really going to do some research, you hardly start with only 20. The next one says the manager of the Bilo supermarket in Mount Pleasant, Rhode Island, gathered the following information on the number of times a customer visits the store during a month. The responses of 51 customers were quantitative data. Do we agree? It's the number of times. Is it discrete or continuous? It's discrete, did you say? You meant discrete. It's the number of times you walk in the store. It doesn't matter how long you spend in there. Now, if it asked about time spent, that would be continuous. It just cares about you entered the door, they counted you in. Okay? And starting with 0 as the lower limit of the first class and using a class interval of 3, organize the data into a frequency distribution. So let's do this one by hand. Just to see how you like doing them both ways. In most cases, when we get up further into the textbook or into the scores, you're going to see that you're going to need the mean standard deviation anyhow, so you're going to always put it into the calculator. But on here, we're going to do this one by hand. So you're going to start, you're going to draw a frequency distribution. So 0 to 3, 3 to 6, 6 to 9. Let's begin. Do you have paper? Okay. And a ruler would be great in this class. So I'm going to start with the classes. And it's told us to start the lower limit at 0. So we're labeling this class. Classes are 3 big. So 0 to 3, 3 to 6. By scanning, can you tell me the largest number? By scanning the data, can you tell me the largest?
15.
5 0? 1 5.
1 5.
Will this be exhaustive? Because I won't include 15 in my last one, right? It's 9 up to, but not including 15. So I need to put one more on. If I followed the 2 to the k rule, how many classes should I have had? Two to the k has to be greater than 51. Oh, I erased them. What's this one? It's 6. Beautiful. Okay, so you're going to do this one by hand. You're going to just count count the number of zeros, 1 and 2. Okay. You should have been, if you didn't want to enter them, you can count them by hand, right? So you had a choice here. You could count them by hand and use the calculator to check. You could just count them by hand right off the page. And the question says, describe the distribution, and the cluster we would say would be in the first 3 classes. So let me fill this in though. And what will this total? 51. If it doesn't, it means that either I've missed when I've counted it, or I haven't got a class for each one of my numbers. In other words, it's not exhaustive. Questions about any of what's gone on here today? Because now we're into the textbook. We'll be working through the textbook, but using our calculator, using ourselves to count. You'll be graphing, so you'll want to bring pencil, ruler. Everybody's happy. So remember, I guess at the Y max. When it's a frequency, I guess the biggest Y max could be is half the data. That's just a guess. But if my histogram is chopped off, I know I haven't got it big enough. If it's squashed like this, I know I need to make it Y a different size. Questions about any of this? Do you love your calculator yet? I hope so, because we could quickly do the mean of this as well, and we will be doing that very shortly. And tomorrow is the lab, yes? It's Kia tomorrow. We have done all of chapter 2. And if you were looking for some to try, I would suggest the blue pages. Question 31, 32, 35. There's some good ones. The book is also great. This is on page 46. Question 31, 32, and 35, 36. The book is also great because if you look in the back, they are not just answers, they are solutions. Remember that the solutions are also for those people that don't use the calculator. So a lot of times they've done everything by hand that you will have done automatically on the calculator. But there are solutions back here. So I'm suggesting that you do 31, 32, 35, and 36. Be good if you have time before I see you again. Tomorrow on Kia, there will be questions from chapters 1 and 2, and you can do it as many times as you want. I record your best result, and I will add your Kia marks to your hand-in assignment. But the idea of Kia is to get you reading and being able to do multiple choice. Goodbye.
The website for the course, does everyone have the website address?
Matt?
Do you want to just drop it down? I just checked, and the first lesson is there. The second lesson is being put there as we speak. There's 3 separate videos on just using the calculator. So if there's something you're struggling with, lists, histograms, whatever, there's videos about just that as well. You're graphing everything in this one. You can learn anything in y equals.
So anything that you have missed will be there. The page, and Adam, will you put up that they are to do question 31, 32, 35, and 36?
Can you write it down? I'll put it there in a second. Yep.
Wait.